Good evening, everyone. So I wanted to make a couple of short videos, uh, more or less just explaining the sorting algorithms we covered in class. One thing I have learned through the years of teaching this class is that this chapter, this section of the class is evil. The reason I say that, it is the most boring to listen to and the most boring to teach. But I think there's something you can learn from this. So, first one we are talking about is BubbleSort. BubbleSort is a very, very simple algorithm. So, on the screen, I have a nice 7-element array, and I want to show you how BubbleSort is going to approach sorting this. So, first thing I'm going to do is rewrite this in my own handwriting, just so I can see it and think about it better. And now I want to walk you through the steps of BubbleSort. So what BubbleSort is going to do is start at the first two elements. So we'll say I and j, and we are going to check, hey, is I greater than j? If it is, we swap the two. We swap, and if it isn't, we continue. We go to the next two elements. We'll say swap and continue. And we repeat that over and over and over and over. So, look, oh my goodness. Looking at what we have so far, I'll swap to red. We check, is 6 greater than 11? The answer is no. So we move on to the second set of numbers. And so we say, or our I and j is going to update, so we'll say I is now here, j is now 17. And we ask the exact same thing. We say, is 11 greater than 17? The answer is still no. So, for some reason, my pen does not like erasing. Let me swap to the mouse real quick. Get rid of these. So now we look at the third set of numbers. So 17 is now I, 13 is now j. We ask, is 17 greater than 13? The answer is yes, so we need to swap them. Now, the way that we swap them is the very, very generic C++ way to swap them. I think the code looks something like int temp temp equals whatever the array is at I becomes j, and j becomes temp. So, whenever we end up swapping them, the array is now going to look like 6, 11, 13, 17, I think it's 8 and 16. That sounds right. Yes. So, this is going to be after our first swap. So swap 1. But we're not through the full loop yet. So now that we have swapped, we need to continue. And so 17 and 18 become our new I and j. We need to ask, are these, apologies, got an email, is 17 greater than 8? The answer is yes, so we swap them. So we go back up here and we do that fun little code, and our array becomes, I'm only going to change the part that changed, 8, 17, 16. We do it one last time for this run, and we compare 17 and 16. They do need to swap. 16 is smaller than 17. And so our final array after the first run is 6, 11, 13, I just lost my train of thought. 8, 16, 17. I feel like I lost a number. Did I lose a number? No, I didn't. So, this is our element after the our array after the first run of I. First run of I. So, now that we have that, we know that 17 is in place. We do not have to touch it again. So, going back to the rest of our loop, we reset I and j, and we repeat the process again. So, going up to draw, we quote-unquote run the gauntlet. 6 is smaller than 11, so that's fine. Scribble these out. I becomes 11, j becomes 13. Those are smaller. Skip ahead. It becomes 13, j becomes 8. 13 is larger than 8, so we need to swap. So I will write swap right there. Come down here. Let's go ahead and rewrite our array. So 6, 11, 8, 13, and 16, and 17. We don't care about that right now. So we check one more time. Is 13 greater than 16? It is not. And so we know that 16 is the next largest in our array. We now baby gate it, since we know it's the second largest, and we run the process again. So this time with our array, what is happening? Good lord. With our array of 4, we compare 6 and 11. That does not swap. We compare 11 and 8, and that should swap. So after this step, we will have 6. Yeah, that's what I wanted. We're ignoring it. Pretend it never happened. 8, 11, and 13. We walk through, we compare 11 and 13. That's good. We baby gate it off, and then at this point, we walk through the numbers just one more time, technically 2 more times to make sure that they're sorted. We'd compare 6 and 8, 8 and 11, that's good. We baby gate 11, compare 6 and 8, that's good. So we baby gate 6 and 8. So at the end of the day, our sorted half of the array, which is now the full array, is 6, 8, 11, 13, 16, and 17. So the way that I want you to remember what BubbleSort is when you were a kid and you would blow bubbles, you would want either a mass amount of bubbles or a large bubble. So BubbleSort deals with the largest. Yeah. So you all should have access to the code. Practice this by hand and just kind of play around with it and get a feel for it. I will see you all in the next one, which I think is selection sort.